Hello and welcome to another video. So this video is just going to cover virtually everything we've learned in this series, and this is what I call a composite function because it combines one characteristic of functions with another. For example, this is a radical function over a rational function. So in order to determine the domain of these functions, you will have to know what the rule is for this kind of function and what the rule is for this kind of function. So let's start from the outside and then we go to the inside. Okay, so, and it's just a good way for you to identify all the critical numbers you'll be dealing with. So the first thing is we want to say if you take the square root of a number, that number has to be positive or it has to be zero. So there are two possibilities of what we can get with this expression. So this expression can be is either positive or zero. Okay, firstly, when is a rational expression equal to zero? That only happens when the numerator is zero. Okay, so we might want to quickly address that and say, when will this expression in here be zero? So remember, you're looking for values that are greater than zero or that are equal to zero. So let's first start with equal to zero, and then we can deal with greater than zero for the entire expression. Okay, so we can say that, so to get our critical values, so the first critical value is when this expression is equal to zero, and that happens when the numerator x squared minus 5 is equal to zero. And that tells us that x squared is equal to 5. So x is going to be equal to plus or minus the square root of 5. Okay, so if we decide to, let's just do our line test. We're going to try to do what we're supposed to do here. So I have here negative square root of 5, and then I have a positive square root of 5. Okay, so we're going to keep this. We'll talk about what to do with these two numbers, but it's important that we know that. Okay, so remember, because we're dealing with a radical function, what we have here must be 0 or positive. So these are the values that will make it 0, which means we can legitimately include these two values in our domain because the square root, the number under the square root sign is allowed to be 0. Okay, now, but if you look at this expression, we also want it to be positive. Okay, so if you want it to be positive, we might as well just check what intervals will be positive. But before you go, you want to get the next critical value because what you have here is a rational expression. And remember, we would not even start this conversation if what you have here is not defined. Because if it's undefined, then this function does not even exist. It's a joke. And the only reason this function will not be defined is if the denominator is equal to 0. And that happens when x equals negative 3. So we know negative 3 cannot be a part of our answer because x cannot be negative 3. So we can say that negative 3 is a critical value. We have to take note of that. It cannot be a part of our answer. So where will negative 3 be here? Well, negative 3 is likely to be here because negative 3 is less than negative square root of 5. Okay, so these are the three critical values that we have. We just want to make sure that yes, truly, we can include this and this in our answer. We cannot include this. We also need to know that whichever part we include is positive because the argument of a radical function must be positive or at least be 0. Okay, so now let's do our sign test and we'll see what our domain is going to be. So there are two things we need to consider here. We need to consider x squared minus 5 and consider x plus 3. So I'm going to write x squared minus 5 and x plus 3. We'll see the combinations that we have. So we're going to test 4 regions. So what's going to happen when we take a number from here? Let's say we take negative 4. If you square negative 4, you're going to get 16. 16 minus 5 is a positive value, so this is going to be positive. Okay? We put negative 4 here. This is going to be negative. So you notice we have a combination of positive, negative. This region is definitely negative, so we don't want this region. Okay, we don't want that region because the region we want is the region that makes this positive. So let's go here. Let's pick a number between here and here. I'm going to pick negative 1. It's an easy, no. It's tight. Okay, because this is between 2, this is between 2 and negative 2 and negative 3. So let's pick negative 2.5 because the square root of 5 of rad 5 would be negative 2.2 something. Okay, so let's pick 2.5. If you square 2.5, it's negative 2.5, it's going to be positive 6.25 and then minus, so this is going to be positive. That's good. And then negative 2.5 plus 3 is going to be positive too. So this region actually is positive. So I'm going to take it. So what number is between this and this? Oh, 0 is a good number here. So let's just take 0. If we put 0 here, this is going to be negative. If we put 0 here, this is going to be positive. Okay? and negative positive is going to be negative. We don't want this point. Okay, the last one. Any number greater than this, let's say we pick 3. This is going to be 9 minus 5, and that's going to be positive, and that's also going to be positive. Okay, sorry, it's a positive. So you end up with 2 regions that you need to write as your domain. The regions with the check marks. Starting from here, see, we can't go that way. It starts from here. The only regions are these regions and these regions. And see how I'm going to shade it. So if you're coming from infinity, you cannot add this point, but you can add this point. You can also add this point. Remember, those are the points that make the expression 0 and everything that goes this way. So we need these points, wiggly, 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 till this point. We also need wiggly, 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 wiggly to infinity. So the domain of this function you're looking at is, starting from this point, negative 3, goes all the way to negative square root of 5 with this, and then union, it starts again from this, square root of 5, and goes all the way to infinity. And this is the domain of this function. Okay, let's go to this one. So this function actually combines 4 functions. It's a composite of 4 functions. This is a logarithmic function. What you have is an exponential function. What you have is a radical function. And what you have here is a rational function. So we have to apply all the rules. Remember, you want to start all the way from outside. It makes things a lot easier. So for you to take the logarithm of anything, what you're taking the logarithm of must be strictly greater than 0. So which means the top cannot be 0. There cannot be any way this will be 0. And so let's look at it. This is an exponential function. We know it's impossible for an exponential function to be 0. So we're good. Okay, because what we have on top is an exponential function. We don't need to go through the trouble we went through trying to solve this, because no matter what you do, this will never be 0. So that's safe. Don't worry about it. Okay, now, also, since we know this cannot be 0, well, again, the denominator cannot be 0 for any rational expression. So this whole expression cannot be 0, which means this cannot be 0. Do you see that? So the bottom expression cannot be 0. That means 4x cannot be 0. So let's start identifying all critical values. So, critical value. So you have x cannot be 0. Because if x is 0, x cannot be 0. Because here, if this is 0, the denominator is going to end up being 0. And that makes this expression undefined. So we have to go in here and say, x cannot be 0. So we've identified that. Secondly, the bottom part of this rational expression also cannot be 0. X minus 3 cannot be 0, which means x cannot be 3. So you want to identify that. X is not equal to 3. I think basically, okay, so now that we're done with that, the next thing we want to do is say, you know what? This argument cannot be negative either. Okay? Is there a chance it might be negative? Yes. X minus 3. It is possible for you that this expression is negative. It's also possible that this cannot be negative. Under the square root sign, you can't have a negative. So that simply means when you take care of what's under the square root sign, you're taking care of the entire argument, because this is always positive. Remember, you might need to write that 2 to the x plus 1 is always greater than 0. Always. Because it's an exponential function. But what you have here, well, is only valid when this is positive. So we might need to take care of this expression and see where we might have trouble with positive or negative. We know it cannot be, x cannot be 3, but we still need x. We still need this expression to be positive. So now, let's get our critical value. So for x, we have x minus 3. We want to make sure this is always positive for the values we're going to use. So this is our number line. We have the numbers 0 and 3. Okay, if you pick a number on the left of 0, say negative 1, you plug it here, you're going to get a negative. If you plug negative 1 here, you're going to get a negative. Negative, negative will give you a positive. So we're going to take this part because this is going to be positive. Okay? Now let's go here. Pick a number between 0 and 3. I'm going to pick 1. Put 1 here, this is going to be positive. Put 1 here, this is going to be negative. So this is a negative region. We don't want it. Okay, now let's go to the third part. Let's pick a number 4. This is going to be positive. this is not going to be, this is also going to be positive. So we're going to take this region because positive, positive is positive. So now see what we've got. We've got a region. The regions we want are the regions that are on this side and on this side. Okay? So I think basically that's the domain of this function, because now we know that we can take the square root of this, and if we divide this by this, we're going to get a value that is not 0 and that is not negative. And it looks a bit complicated, but it's even a lot simpler than what we did on this side. So this is it. That is the domain, because this was the problem that we had. This was not a problem. So our answer, domain. So remember, can x be 0? X cannot be 0, and x cannot be 3. So we're going to put this here, and we're going in this direction. Also going in this direction to positive infinity. So it's negative infinity to 0, okay? And from 3 to positive infinity. That is the domain of this function. Never stop learning, because those who stop learning have stopped living. I'll see you in the next video.